Hello, welcome to our online chemistry class for class 12. I am Thiaw Bang Chu, and I'll be your chemistry tutor during this lockdown period. Today, I want to start with a topic from your physical chemistry part, that is solutions from your unit 2. If I ask you what a solution means, I'm sure that many of you will be smart enough to say that a solution means an answer. And you would be absolutely right. But in your chemistry exam, if you're asked what is a solution, and if you write a solution is an answer, then you won't get any marks. Why? Because in chemistry, it means an entirely different thing. So, what is a solution in chemistry? Let us try to understand that. If you have a book and pen, you please try to note it down. Solution in chemistry means a homogeneous mixture of two or more substances. Let me repeat it again. A solution is a homogeneous mixture of two or more substances. Now, what do we mean by a homogeneous mixture? A homogeneous mixture is one in which the composition is the same throughout the mixture. That means the composition is uniform throughout the mixture. For example, if we have a solution of sugar dissolved in water, you put sugar in the water, the sugar gets dissolved in the water, and if you taste that solution from any part, maybe you can take it out from the top, from the middle, or from the bottom, you taste it, you'll find that the taste is the same from any part of the solution because the sugar has been dissolved uniformly in the water. Such kind of mixtures are called as solutions. Now, today, our discussion will be confined to a certain kind of solutions, which we call as binary solutions. What is a binary solution then? It is a kind of solution which is made up of only two components. Like I said in our definition, a solution is a homogeneous mixture of two or more substances. So it may contain only two components, or it may contain more components also. But in a binary solution, we have only two components. Now, out of these two, one is called as the solute, the other is called as the solvent. So which is the solute, which is the solvent? The component that is present in smaller amounts is called as the solute. The one which is present in larger amounts we call as the solvent. But in certain cases, we might find that both components are present in the same amount. So in such cases, the one which is dissolved will be called as the solute, and the one in which the solute is dissolved will be called as the solvent. Now, before we go further into a detailed discussion about these solutions, let me try to convince you why we need to study about these solutions. Solutions, they are an integral part of plant as well as animal life. And if you just look around, you'll find that we are surrounded by solutions. There are so many kinds of solutions around us. For example, the tea that we drink, the smoke that we find in our kitchen, the air around us that we breathe, all of these are different types of solutions. Many chemical reactions are also carried out in solutions. And even our body fluids, they are solutions of different types of compounds dissolved in water. Now, in cold countries, people use antifreeze solutions in the radiators of their automobiles. Why do they use that? Or the body fluid of a dehydrated person cannot be replaced just by ordinary water. Why do we use saline solutions in such cases? All of this you will understand after going through this unit, that is solutions. Now, we have different types of binary solutions also. If you look in your textbook, you'll find it in page 36. There is a table, figure 2.1. Please try to look that up in your textbook. You'll find 9 different types of solutions given there along with examples. So basically, there are 3 types of solutions. One is gaseous solutions, then we have liquid solutions, and then we have solid solutions. The solutions in which the solvent is a gas, those are called as gaseous solutions. Those in which the solvent is a liquid, they are called as liquid solutions, and those in which the solvent is a solid are called as solid solutions. Gaseous solutions, again, can be classified into 3 types: gas dissolved in gas solutions, liquid dissolved in gas solutions, solid dissolved in gas solutions. Like that, liquid solutions can also be of 3 types: gas dissolved in liquid, liquid dissolved in liquid, or a solid dissolved in liquid. And finally, solid solutions also can be of 3 types: gas dissolved in solid, liquid dissolved in solid, or gas dissolved in solid. And so in total, we have 9 different types of binary solutions. Please look up the examples of these different types of solutions in that diagram, in that figure in your textbook. Now, the amount of solute that is dissolved in a given amount of a solvent in a solution is called concentration of the solution. Once again, concentration of a solution, it is the amount of solute that is dissolved in a given amount of the solvent. Now, there are different ways of expressing concentration of a solution, and today we will try to understand some of these ways of expressing concentration of a solution. The first method for expressing concentration of a solution is mass percentage. Now, mass percentage of any component in a solution will be given by mass of that component divided by total mass of the solution multiplied by 100. Let me write it down here. Mass of the component divided by total mass of all the components, and this is multiplied by 100. Mass percentage of any component can be calculated like this. So if we have 10 grams of glucose dissolved in 100 grams of water, what will be the mass percentage of glucose in this solution? Mass percentage of glucose will be given by mass of glucose divided by total mass of all the components. So mass of glucose plus mass of water multiplied by 100. So we have, in the solution, we have 10 grams of glucose. So we take 10 here, then mass of glucose plus mass of water, that is 10 plus 100, we get 110. And this finally we multiply by 100. I know you will be able to do these calculations at home, so please try this and I'll give you the answer in the next class. The second method for expressing concentration of a solution is volume percentage. So instead of mass, we use volume here. In the second one, we use volume of the components. So instead of mass here, we use volume. So volume percentage of any component in the solution will be given by volume of the component divided by total volume again. Total volume of all the components multiplied by 100. So if you are going to calculate volume percentage, then this should be given in volumes, not in masses. So suppose we have 10 gram of glucose again, 10 ml of glucose dissolved in 100 ml of water. The same calculation. Volume percentage of glucose in the solution will be volume of glucose by total volume, that is volume of glucose plus volume of water multiplied by 100. So basically it is the same. The only difference is in the first one, in mass percentage, we use mass of the components, whereas in the second one, we use volume of the components. The third one is mass by volume percentage. So in this one, we use mass as well as volume. Mass by volume percentage. So mass by volume percentage of any solution will be given by mass of the solute that is dissolved in 100 ml of the solvent. So here we use mass of solute per 100 ml of the solvent. So mass of the solvent is used here. And this is multiplied by 100 to get the percentage. This is the third method. This mass by volume percentage, this method of expressing concentration, we usually find in medicines or in pharmaceuticals. For example, if you go to a pharmacy to buy a bottle of hydrogen peroxide, you will find that in the bottle it is written either 3% volume percentage of hydrogen peroxide or 6% volume percentage of hydrogen peroxide. So usually in medicine or in pharmaceuticals, this method of expressing concentration is used. The fourth method that we have for expressing concentration of a solution is molarity. So what is molarity? Molarity, it is defined as the number of moles of the solute per liter of solution. Number of moles of solute per liter of solution. Now, molarity can be expressed like this. We use capital M to express molarity. Molarity of the solution will be given by number of moles of solute divided by volume of the solution in liters. So if we are to calculate molarity of a solution, what we need to do is first find the number of moles of the solute. What is number of moles, or how do we calculate number of moles? Number of moles, it may be of the solute or for the solvent also. For any component in a solution, number of moles is given by mass divided by the molar mass. So using this relation, first we find the number of moles of the solute, then this we divide by the volume of the solution in liters. Now in many of your problems, you will find that the solution is expressed in milliliters, not in liters. So if volume of the solution is given in liters, ml, then molarity will be given by number of moles of the solute, which we can write as NB, divided by volume of the solution. Let us just write V for that. If volume is given in ml, not in liters, then this expression will multiply by 1000. This will give us the molarity of the solution. Let us see one example here. Suppose we have 10 gram of sodium hydroxide, 10 gram sodium hydroxide dissolved in 100 ml of solution. If we have 100 ml of a solution in which 10 gram of sodium hydroxide is dissolved, what should be the molarity of the solution? We have molarity equal to number of moles of the solute divided by volume in ml, and this multiplied by 1000. So molarity for the solution will be equal to number of moles of the solute. Here sodium hydroxide, it is dissolved in water or in some other solvent. So this is dissolved, so this forms the solute. So mass of the solute, we have 10 gram. Molar mass of sodium hydroxide, we calculate from the given formula. So we have NaOH. To find the molecular mass, we just add up the atomic masses. Atomic mass of sodium is 23. For oxygen, it is 16. Hydrogen, its mass is 1 only. So what should be the molecular mass? We get 40. Molarity is number of moles of the solute divided by volume of the solution in ml into 1000. To get number of moles of the solute, what we do is divide the mass of the solute by its molecular mass. So first, we take mass of the solute, that is 10 gram, divided by the molecular mass of the solute, that is 40. This gives us the number of moles of the solute. Then we have volume of the solution, which is 100 ml. And finally, we multiply this relation by 1000. What do we get? We get 10 divided by 4. So molarity of the solution should be 10 divided by 4. We get 2.5 molar, or this molarity can be expressed in terms of moles per liter. Now, the fifth method for expressing concentration of solution is molality. Molality is defined as the number of moles of solute per kilogram of the solvent. Number of moles of the solute per kilogram of the solvent. So in molarity, we used volume of the solution, whereas in molality, we will use mass of the solvent in kilograms. So molality, which is expressed by this small m, will be given by number of moles of the solute divided by mass of the solvent. Just write WA. For that, this should be in kilograms. And this whole is multiplied by 1000. So once again, to calculate molality also, we need to find the number of moles of the solute. Then we divide that by mass of the solvent in kilograms, whereas in molarity, we divide it by volume of the solution in liters. So once again, if we take an example where we have a solution in which 64 gram of methyl alcohol if we have 64 gram of methyl alcohol dissolved in 200 gram of water, suppose, what should be the molality of this solution? Molality will be given by number of moles of the solute, which is again given by mass of the solute, that is 64 gram, divided by its molecular mass. Now, methyl alcohol, its formula is CH3OH. So once again, we add up the atomic masses to get the molecular mass. Mass of carbon is 12. Hydrogen, we have 4 atoms of hydrogen here. Each mass of each hydrogen is 1. So total mass of the 4 hydrogen atoms should be 4. Then we have oxygen, whose atomic mass is 16. So what should be the molecular mass? We get 32. The molecular mass of the solute, methyl alcohol, is 32. Its mass in the solution is 64. So this mass of the solute we divide by its molecular mass, that is 32, to get the number of moles. Then mass of the solvent in kilograms, whereas here mass of the solvent is given in grams. So if we have this mass of the solvent in grams instead of kilograms, we multiply this by 1000. Now here, molality is number of moles of the solute divided by mass of the solvent in kilogram. If this is in kilograms, we will not be using this. However, if mass of the solvent is given in grams, then we will be multiplying this by 1000. So since here mass of the solvent is given in grams, we multiply the relation by 1000. So what should be the molality of this solution? Molality should be 10 moles per kilogram. In molarity, we express it in terms of moles per liter. In molality, we express in terms of moles per kilogram. Finally, we have the last method for expressing concentration of solution. This is called as mole fraction. This is the sixth method. Mole fraction of any component in a solution is given by number of moles of that component divided by number of moles of all the components in the solution. So if we have two components, A and B, making up a solution, we want to find the number of a mole fraction of either one of this. Then we first find out the number of moles of both the components. As we have seen in the previous exercises, number of moles is given by mass of the component divided by its molecular mass. So number of moles of A will be given by its mass in the solution divided by its molecular mass. Number of moles of B will also be given by its mass in the solution divided by its molecular mass. To find the mole fraction is expressed by this X. If we want to find the mole fraction of A, then mole fraction of A, that is XA, will be given by number of moles of A divided by number of moles of both the components. So Na plus Nb. Likewise, if we want to find the mole fraction of the component B in the solution, it will be given by Xb equal to Nb divided by Na plus Nb. So if we go back to the previous problem, the previous solution that we discussed, 64 grams of methyl alcohol dissolved in 200 grams of water. What will be the mole fraction of the components in such a solution? Let us try to calculate that. We have 64 grams of methyl alcohol dissolved in 200 grams of water. So first we find the number of moles of methyl alcohol as well as that of water, and then finally we can calculate the mole fractions. So we have mass of methyl alcohol, which is 64 grams. We have calculated its molecular mass, that is 32. So number of moles of methyl alcohol, let us write CH3OH, number of moles of methyl alcohol will be given by its mass in the solution, that is 64, and we divide this by its molecular mass, which we calculated earlier, is 32. So 64 divided by 32 gives us 2. Number of moles of methyl alcohol is 2. Then number of moles of water. Number of moles of water will be its mass in the solution, that is 200, divided by the molecular mass, that is 18. For H2O, once again, we add up the atomic masses. Atomic mass of oxygen is 16. For 2 hydrogen atoms, the mass should be 2. So total will be 18, which gives us the molecular mass of water. So we calculate the number of moles of water by dividing its mass in the solution divided by its molecular mass. So 200 divided by 18 should give us around 11.11. After finding the number of moles, we finally find out the mole fraction. So mole fraction of methyl alcohol will be given by number of moles of methyl alcohol divided by the sum of number of moles of both components. So number of moles of methyl alcohol plus that of water. Number of moles of methyl alcohol, we got 2. This will be divided by the sum of number of moles of both components. So 2 plus 11.11. I'm sure you will be able to do this simple calculations at home. You try it. Likewise, mole fraction of water will be given by number of moles of water divided by number of moles of both components. So first we take number of moles of water, that is 11.11, divided by number of moles of water plus that of methyl alcohol, that is 11.11 plus 2. So those are the different ways in which we can express the concentration of a solution. So what did we learn today? Today we have learned what a solution is, why solutions are important in our lives, and we have seen the different types of binary solutions. We have also seen the different ways of expressing concentration of a solution. Now, before I leave, I want to give you an assignment, which I want you to try at home. You try it and give your answer ready. I'll be giving you the answer in our next session. So you please write down this question. Calculate the mass percentage. Calculate the mass percentage of benzene, that is C6H6, and carbon tetrachloride, that is CCl4, if 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. Once again, quickly, calculate the mass percentage of benzene, that is C6H6, and carbon tetrachloride, CCl4, if 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. Please try this at home, and I'll give you the answer in the next session. Till then, stay safe and study well at home. Thank you.